Hello, everyone. In this video, we're going to begin section 6.1, where we're going to be using the definite integral to find area. So now, before we get into this topic, I just want to introduce this chapter a little bit. So all in chapter 5, what we were working on was finding and learning about methods for computing integrals, which, as we saw in our chapter 4, an integral of a function computes the area underneath the function. So in chapter 6, rather, we're going to look at some different applications of integration and integrals. So in particular, the 6.1, using the definite integral to find area. Well, we've already done this in some of our previous chapters of using an integral as an area, because that's what an integral is. However, the application that we look at in this section, 6.1, is when we're computing area between two curves. So let's get started by looking at this goal here. So in this example, we want to derive a general formula for the area between two functions, where we're calling them y for f of x and y, also the same output values for g of x, on the interval from a to b. So if we see our picture here, what is going on? But we have a function f up here, g down here, and we want to compute this area in between the two curves. Okay, and again, before what we were doing was computing area, just say under one curve or the other, maybe under g, for example. And we saw that the integral of g of x from a to b. Okay, cool. So the way we're going to think about this is the way that we thought about our usual integral over one function in our previous chapter. So what we're going to do is look at how we would approximate this area using rectangles. So let's focus on one rectangle in particular and see if we can make sense of what the dimensions of this rectangle should be. So here we have one right here. So here we have a partition of our interval from a to b. And we can call these values x sub 1, 2, 3, etc. So a general one, we'll call this right side x sub I. All right, so if we want to talk about the area of this particular rectangle, how would we talk about it? Well, if we notice, we want to compute the width and the height of this rectangle. Well, the width of this rectangle, we can just call the change of x. It's a change of x amount. And it's very typical of what we've been seeing before in subdividing interval. So we'll call that delta x. So delta x is just the width of the rectangle. So then what about the height of that rectangle? So if we notice, if we look at the entire rectangle all the way from the x-axis to the top of our rectangle, well, that's just the value of f at xi. So this total amount is f of x sub I. But we don't want to include that total amount. How much do we want to subtract from this length? Well, we need to subtract all of this amount. And if we notice, all of that amount is just the value of g at x sub I. So then if we want to just compute the height of that rectangle, well, we already have the width as delta x. The height is just going to be f of x sub I minus g of x sub I. We're going to go all the way to the top of f, but then subtract what we don't want, which is the g value. Okay, so the area then of this one rectangle would look like the following. Area of one rectangle would be delta x times f of x sub I minus g of x sub I. So then if we want to do this, not just for one rectangle, but all of these I rectangles that we have making up the area between these two curves, then we need to add up all of these areas. So what would that look like? Well, that would look like a sum where we take I goes from 1 to n of delta x. So each term has a delta x. And then we just vary f of x sub I minus g of x sub I. And now we've seen this notation before. We've talked about it just briefly in class. But what this would amount to is just a shorthand way of saying that we want to take a sum. So we're going to add up n terms that look like this. So we start with when I equals 1. So that would just look like the first term, delta x times f of x sub 1 minus g of x sub 1 plus delta x. Now we're letting I equal 2. So f of x sub 2 minus g of x sub 2. So that would just be the height of the second rectangle. Then we just continue doing this until we reach our final rectangle, delta x times f of x sub n minus g of x sub n, the height of our nth triangle. So again, this is just shorthand for that long sum. Okay, so let's just clean this up a little bit. So what we've written here in this sum is an approximation of that area in between the two curves. So if we want to get an exact area between the two curves, then we need to have this, the number of rectangles, n, needs to go to infinity. We need many, many, many rectangles, and that would mean the change of x needs to go to 0. So as we do that, so I'm going to say let the change of x go to 0. What does this sum become? Well, what that means is that we are getting smaller and smaller widths. So as an integral, we would go from a to b of f of x minus g of x times delta d of x. So then here we have our formula for the area. So area between f and g. So in general, we don't have to use these rectangles to build up this formula. So when you see problems like this, you can just go ahead and deploy this formula. The important thing, though, is being able to determine which function is first and which one we are subtracting. So if you're just starting with a graph like this one shown here, and we want to determine, well, which, we know that we're going to compute an integral of a difference. And we want to know, well, what function do we start with? So what is helpful is to draw a line that is perpendicular to the line that we are differentiating with respect to. So here I'm sort of drawing an outline of what not a rectangle would look like, but what a slice of my integral looks like. So we have d of x, so that's why we're perpendicular to the x-axis because we're chopping with respect to x. And then what we can do is just read off what the dimensions or values of this line are. So here we see that the top or largest function is f, while the smaller one is g. So that means we want to subtract g from f. All right, thanks for watching. In the next video, we will look at example 1 together.